today. So I'm a research associate in the Turing-Roche partnership, and what I work on is clinical AI and how to integrate it into clinical workflows. So to this goal, a clinical model should be, most of the cases, multimodal, and it should be suitable for human-in-the-loop flows in general. And as we just discussed, it's very important that they satisfy regulations, and in a way they fight against this opacity crisis, and so they must be transparent. And to me, this means overall that these models should really reason in terms of the same concepts that human experts use, in this case clinicians. They should expose their reasoning in terms of the same concepts to allow for human supervision, and they should also enable human intervention to essentially correct the model reasoning. And the simplest example of these models are concept bottleneck models, where the task prediction is factored in two stages. So first you predict human interpretable intermediate concepts, and from these then you make a task prediction. And for interpretability, the task prediction should really only be based on the level of activation of concepts, and no additional information should really flow from the input to the task without human supervision. However, there is a subtle effect for which this can happen, and this is called leakage. And so the idea is that during training, additional information may be stored into the learned concept to achieve a better task performance. And this manifests, for instance, as additional structure in the learned concept distribution that now encodes information about the other concepts and the task. And this means that in practice, the learned concepts are no longer aligned with the ground truth human interpretable concepts. And so, for instance, a clinician that intervenes on a learned concept stage may actually be intervening on a concept that is a mixture of stage, grade, and even response, making the model essentially uninterpretable. And this problem is even more severe in multimodal setups where, as I think we mentioned, interpretability is harder to audit. And this is the case because, well, in practice, evidence for a concept may be distributed across different modalities, and in general, intervention and supervision on in a multimodal setup require a consensus by a team of multidisciplinary experts. And so, although being, I think, the most important problem of concept-based models, there was no reliable measure of leakage and, in general, interpretability for the class of models. So this is why we, in this work here, you don't see the cursor, we tackled this issue, and we proposed a new framework based on information theory to understand, measure, and prevent leakage. Yeah. And the core idea is that if leakage is present, then learned concepts will be more informative about the task than the ground truth. And so here are some scores, the concept leakage scores, concept task leakage scores, that formalize this idea, and there are more in the paper, of course. But what we found through a series of experiments and across data sets and models is that this approach and these measures are actually quite sensitive and robust. And this allowed us to prove, for instance, that concept embedding models, which are often perceived as state-of-the-art concept bottleneck models, are actually not interpretable, and they display high level of leakage in general. But these scores and this framework is so sensitive that they actually allowed us to gain a new understanding of leakage and interpretability in concept-based models, and allowed us to identify the primary causes of leakage themselves. And so, for instance, we saw that in general, if leakage is favored if you have insufficient concept supervision during training, if you choose an overexpressive concept encoding, so say a concept is in ground truth a binary, but you encode it as a logit, for instance. If you have an incomplete set of annotated concepts that are insufficient to specify the task, or if you have a misspecified final head architecture. And this led us to propose a protocol essentially to design your model and design its training strategy to ensure interpretability and to prevent leakage. And the idea is that you first should understand whether your annotated concepts are really sufficient for the task you have in mind before delving into the concept encoder, its training, and its design. And this is especially relevant, I think, for multimodal setups where the concept encoder is typically quite large. And yeah, yeah, if you have any, if you'd like to chat, let's discuss on my poster. Thanks.
Yeah, thank you, Enrico.